Okay, we now have a problem where we're going to have two blocks, one block on an inclined plane, one block connected to it by a rope over a pulley, massless, frictionless pulley, and the surface is frictionless. So what we want to do is find out which way do the blocks move, how fast are they accelerating, and what's the tension in the rope. Yeah? So, the way to start is the way we start all of them. We're going to start out with free body diagrams. I call this block M1 and this block M2. So for block M1, our free body diagram has M1G going this way, tension going up the incline, normal force perpendicular to that, and since there's no friction, that's all we have. So we're going to do our usual, make our gravity, this becomes M1G sine of theta, because remember this is theta, and down here this is M1G cosine theta, going that way. Okay? No friction, so that's all that is on there. Now let's do block M2. So for block M2, we have just this. M2G going this way, tension going this way. All right, the first part of this problem asks us, which way do the blocks move? Well, if you notice M2G here and tension determine which way this moves. If tension is bigger, it's going to move up. If M2G is bigger, it's going to move down. But that tension is equal to that tension. So if those two tensions are equal, what we really have to do is see is this part bigger than that part, or vice versa. So what we're really trying to find is M1G sine of theta greater than, equal to, or less than M2G. Because that'll determine which way the block's going to move. So what we do is we know these numbers, I'm just going to plug them in. So M1 is 4 times 9.8 times the sine of 35. M2G is 2 times 9.8. Let's just figure out which one's bigger. So when we do that calculation, we get this is 19.6 newtons. And this over here is equal to 22.5 newtons. Thus, this is bigger. What's that tell us? That tells us that this force is bigger than that force, so the blocks are going to be moving to the left. So right here, I'm going to put down that they're going to have a velocity in that direction. In fact, there's not just a velocity, they're going to accelerate in this direction. M1 goes to the left, M2 is going to go up. All right. We have to also be careful. Remember in our free body diagrams, we have to decide which way is positive. I'm going to do positive to the right because that's standard, which means positive is going down for block M2. Now we know if we do this right, our answer should end up with a negative acceleration because the acceleration is that way, but I picked positive that way. All right, so let's do an F net x for block M1. And F net x is equal to t minus M1G sine theta. But it's accelerating, so I replace F net x with M1A. Okay? Then I can solve this for t, and I can say, oh, well, t is just equal to M1A plus M1G sine of theta. Now let's do block M2. It's just going to be equal to the F net x equal to M2G minus t. I just call it x, remember, because our x coordinate just rotated around and is now going down. But this is also accelerating, so this becomes M2A is equal to M2G minus t. So all I'm going to do is plug in this for t. So I'm going to take this t and plug it into that equation. I'm going to do it up here because I'm running out of room. So it's going to be M2A, it's equal to M2G minus, I'm going to distribute this minus to minus m1a minus m1g sine theta. Now, we want to solve for the acceleration. Solve for the acceleration, we've got to get the two accelerations on the same side, so I'm going to add that. So I'm going to have m2a plus m1a is equal to m2g minus m1g sine theta. Pull out the a, and then I'm going to divide by that. So it's going to be end up with ma is equal to m2g minus m1g sine theta all over m1 plus m2. All right, now I've gotten to the point where I know all the numbers here, and I know what I want to solve for is by itself, so I'm going to just plug in the numbers. m2g is 2, so this is 2 times 9.8 minus 4 times 9.8 sine of 35 over 4 plus 2. And you plug all that into your calculator, and you get a value of negative 0.48 meters per second squared. So, we did part A was what direction? Part B, this is part B here. Part A is the direction, so this is part A, we figured out which direction they're going. Now we need to figure out part C, we want to find the tension. Well, that's easy now because we have the acceleration, we can just plug it into this equation right here, or this equation. Wouldn't matter, you should get the same answer. I'm just going to plug in this one because this one's already solved for t. So I'm going to put in here that t is equal to m1a, well m1 is equal to 4. A is negative 0.48 plus 4 times 9.8 sine 35. And when you do that, you should get a tension of 20.6 newtons, or 21 newtons because we only have two sig figures. That's part C. There you go. That's how you would solve that problem. Be real careful about your signs, the positive and negative signs, because you mess that up anywhere in here and the whole thing falls apart. All right, that was that problem.